Hello again, class. We're going to continue the lecture on solving quadratics, and we're going to move into the idea of having A, B, and C all non-zero values. You remember our last, there it is, let me clear it. Last lecture discussed the idea of values of b equals 0 or c equals 0 and certain strategies on how to solve it. And now we're going to take the example of, say, y equals x squared plus 5x plus 4. And so there are actually three possibility or strategies might be the better word of solving an equation like this. Strategy number one is factoring. And factoring is a little bit of an art form. And there are some strategies with regards to factoring. I'll show you the one that I use. I find that if the A value is not 0, or excuse me, not 1 in this case, that would be the value in front of the x here is 1. Factoring could become quite a bit challenging. The second one is completing the square. And that works every single time. And there is some real world technical reasons why you'd want to solve an equation by completing the square. If you were doing some optics and designing a lens, completing the square will give you what's called the foci, and it'll give you the ability to analyze the lens. So it's important. And you'll see that when we get into trig, for those of you heading into trig, there's solutions where you're trying to take and put it into a form of a circle and putting it in the standard form and completing the squares is a useful way of doing that as well. So there are a couple specific applications, real world, where that is important. But by far the most important one is the quadratic formula. And in my lifetime, when I was modeling my circuit or any business formula that ended up being a quadratic, it never could be factored. And so that's kind of a math thing that's kind of fun, but in real world, you don't use that very much. And I was never working on anything where completing the square made any sense. So I personally always use the quadratic formula with regards to that. And so we'll walk through all three of these examples. And what I'd like to do in this case is to walk through this example using all three of these techniques. And you'll see that no matter what technique you use, you're always going to get the exact same answer. So technique number one would be the factoring. And so the idea that I think about when factoring is you're going to look at the value here of the C value. And the idea of looking at the C value is, what are the factors of 4? Well, the factors of 4 is 2 times 2 is 4, right? And then minus 2 times minus 2 is 4. So we have plus or minus 2 as the factors. And we also have 4 times 1 or minus 4 times minus 1. So the factors are plus or minus 1 and plus or minus 4. And so the idea is, especially when the value of A is 1, how do you factor this? Well, you want to take these two factors where we have x, and you want to multiply these two values that you put here, that when you multiply them together, you get the number 4. And when you add them together, you get the number 5. So in this scenario, we would have a +1 here and a +4 here. And so you could see that in this scenario, we would have 1 times 4 is 4, and then 4x plus 1x gives us 5x. So again, that's the strategy that I use. There are quite a few other possibility of strategies for factoring. Feel free to take a look at some of those other ones. Just YouTube factoring, and you'll get a variety of different ways of doing it. And one that kind of makes you fits in your thinking pattern, that would be awesome. This is the one that kind of fits into mine. And during some of our Zoom lectures, if you have any questions on other techniques, please just let me know. Let me clear this one. And let's take a look at the second, and this is the idea of x squared plus 5x plus 4, and we set that equal to 0. And now the idea of completing the square. So the idea of completing the square is the first thing you do is you always take the constant term to the other side of the equal sign. So the strategy would be x squared plus 5x equals -4. And then the next strategy is that you want the a value to be 1. And you can see it's already 1, so we don't need to divide anything out with regard to that. And so that ends up being okay. So the next thing you want to do is you always look at, once you get it into this form, you always look at this number. And when you look at that number, what you want to do is to complete the square, you take that number, 5, and you always cut it in half, and then you divide it by 2. And by completing the square, what you want to do is you want to square that number. And so when you do that, you get 25 over 4. And so when you have that, the idea is that if you add that number to both sides of the equation, you would be able to complete the square with regards to this. So what I mean by that is that if you take this 5x and then you add 25 over 4, and that would equal -4 plus 25 over 4. And you can see it's already kind of semi-annoying with these fractions, etc. But the idea of completing the square is that on the left side of the equal sign, this will always be x plus this number squared, which would be 5/2 squared. And so that's what we mean by completing the square. And again, for people going into optics or trying to manipulate an equation for a circle, you'll find that this technique ends up being quite useful. So what do we have on the other side? Well, what we have on the other side here is -4, and then we have 25 over 4. So what do we do here? Well, let's combine these and see what we get. Well, to find a common denominator, that would be 4. So we would have 4 times 4 is 16, so this would be -16 over 4 plus 25 over 4. So when we combine those, it looks like we will get 9 over 4. So here we would have 9 over 4 on that side of the equation. So strategy now is we want to get rid of that square, right? So the next thing you do is you take the square root of both sides. And remember, when you take the square root is plus or minus. So when you take the square root, that will go away. And on this side, you have x plus 5/2. And so what does this equal? Well, this would be plus or minus. Square root of 9 is 3. And what's the square root of 4? 2. So in this scenario, now we have 2 possible solutions. The first, what we do is we'll bring the 5 halves to the other side of the equal sign, and you will see x equals plus or minus 3 halves minus 5 halves. And then basically what we do in this scenario is you just do the two solutions. So you have x equals plus 3 halves minus 5 halves, and that's the plus one. And then you have x equals minus 3 halves minus 5 halves for the second one. And you can see when you add this together, you get minus 2 over 2, which would be minus 1. And then in this scenario, you have minus 8 over 2, and that would be minus 4. So you can see that the two solutions are minus 1 and x equals minus 4. You remember when we did the factorization? We had x plus 1, x plus 4 equals 0. So again, what are the values of x to make that equation true? It better be minus 4 and minus 1, or we know we did something wrong, right? So when you do that and you plug minus 1 in, minus 1 and plus 1 is 0. 0 times, that would be 3, would be 0. And you can see when we plug minus 4 into that one, you can see minus 4 plus 4 equals 0. And away you go. So you could see that if you could factor an equation, it is by far the easiest way to solve it. I find this to be a super tedious way to solve it, but again, there are certain applications where these will be used. So it's important to introduce it to you, especially for those of you going into trig. You will use this technique to solve equations to get them into circles. Standard format to get equations into a circle form. So the last scenario, and I will take this same equation and use it, is, let me clear this off, is what I'd like to do now is to introduce you to the quadratic formula. And by far the most useful one in real world applications is definitely the quadratic formula. And so if we take a look at this screen shot that I have here, this is the definition of a quadratic formula. And again, it's minus b plus or minus the square root of b squared minus 4ac over 2a. So this scenario is set up in such a way where you just plug in the values of a, b, and c, you plug through the arithmetic, and away you go. And again, in real world applications, I've never had a quadratic that has been derived that could be factored. So I've always had to use this scenario. And the idea with regards to this now is, if you look at this next slide, the value underneath the square root, the b squared minus 4ac. What that implies is it's called the discriminant. And remember that we can't take the square root of a negative number. So if the value of b squared minus 4ac is positive, you'll end up with two solutions, and they will be real. If the value is negative, then you would take the square root of a negative number, and you would see that that values are no real solutions. And so that one's the easiest one. And the third one, which happens very rarely, is that if the b squared minus 4ac is 0. That was what we call a double root, and you only get one solution. And if you look at this equation, you could see that there's a plus and minus in front of the b squared minus 4ac. And the beauty of 0 is, and one of the reasons why it's my favorite number, because arithmetic's so easy, is that plus 0 or minus 0, if you do that to any number, it's still the exact same number. And so the idea of solving the quadratic, using the quadratic formula. Let's use the same equation again and show you no matter what scenario or strategy you use to solve it, you're going to get the same answer. And so this equation again was y equals x squared plus 4x plus, oops, sorry, try that again. It's 5x plus 4. I was flipping my 4 and 5. So the idea here is the way I like to do this is I always like to write these down where the a value is 1, the b value is 5, and the c value is 4. So again, you don't have to memorize anything. Let me just write the quadratic formula here for you. And it would be minus b plus or minus the square root of b squared minus 4ac all over 2a. So what I like to do and what I would highly recommend is first calculate the discriminant first. What's underneath the square root? Because if that value is negative, you don't need to plug any more numbers in because you will have no real solutions with regard to that. So let's do that one first. So what is b squared minus 4ac? So b squared is 5, so that would be 5 squared minus 4 times a, which is 1, times c, which is 4. So you get 25 minus 16. And that would be 9. So what's the square root? Well, what's the square root of 9? That's the nice number plus 3. So we're in good shape. So what I would do now is finish the equation. So again, the minus b would be minus 5. And then we have plus or minus the 3, which we just calculated, all divided by 2 over 1. So now we're going to have two solutions. Solution number 1 is minus 5 minus 3 divided by, or excuse me, plus 3 divided by 2. And when you do that, you get minus 2 over 2, which is minus 1. That's the first solution. Second solution would be minus 5 minus 3 over 2, right? And so now we have minus 8 over 2, which is minus 4. So you could see one value of x is minus 1, and the second value of x is minus 4. So now you could see that the three different scenarios with regards to the same equation. And so personally, this is the one that in the real world applications, unless you're doing specific manipulation of completing the square, in real world, you're going to end up using the quadratic formula quite a bit. The good news is calculators, you could just sometimes plug in A, B, and C, and out will come the answers for you, which is kind of nice as well. But what I'd recommend is kind of practicing setting it up this way with regards to that. So this will end the quadratic lecture for this part. I'm going to do one more quadratic lecture and put a couple more complicated equations and show you how to solve those. So with that, I will stop this recording.